Hello and welcome to the third episode of Basic Arithmetic, the last episode. This series has gone pretty quickly, just because it's basic knowledge that you should know and better to get onto the exciting mathematics quickly. Okay, so today we're going to be dealing with scientific notation and absolute values, which you will definitely need later on. The scientific notation is pretty much useful in lots of science, hence the name. Mostly in physics when you're dealing with really large numbers. You don't really want to be writing numbers with 16 zeros like 85 million billion. It'd be a bit confusing writing all those zeros. So that's what scientific notation does for us. Okay, so let me just write examples. Example. Okay. And I'll explain what we do. So example 1 is write 320 million in scientific notation. Okay. Well, you can see here that we have 1, 2, 3, 4, 5, 6, 7 zeros. So that would be the equivalent of writing 32 times 10 to the power of 7. But in scientific notation, we always want just the one, we want one figure, so we want just 3. So the way we'd write this is 3.2, so we take this extra and we add it to that, so we get 10 to the power of 8. And you can kind of see how we got 8 digits here. We got 1, 2, 3, 4, 5, 6, 7, 8 digits, and that's where we get the 8 from. That might be a little tedious at the start, so we're going to write 7.1 times 10 to the minus 5 as a decimal, of course. So 7.1 times 10 to the minus 5 equals 7.1. Now, if you remember back in the index laws, this would be just the equivalent of writing 10 to the power of 5, or 1 on 10 to the power of 5, which is the same as writing 7.1 times, divided by 10 to the power of 5. Whoops. That's correct. Okay, so it's just using the index law, you change it to this, okay? And then you can take the reciprocal of it, and that's equivalent to dividing by it. And pretty much you just type that in your calculator, and you get 0.00071. Okay. What else? Okay. That's pretty much all for scientific notation. It's pretty straightforward. I'll do maybe one more example, if I can find one. Here we go. Right, this is a smaller number. Write 3,800 in scientific notation. Well, 3,800 equals. Okay. So you can see we have 1, 2, and 3 digits. So that's pretty much just equal to 3.8 times 10 to the power of 3. Okay. Again, you place the decimal place in front of the first digit, or sorry, behind the first digit, so in this case here, okay, and you take the amount of digits that's behind it and you add it to a power of 10. So that's, 3.8, I'll write it a bit clearer. That's the answer. Now we'll do absolute values. Absolute values. The absolute value of x equals x or negative x. Okay? Pretty much it equals x when x is greater than 0 and when x is lower than 0. That's the definition of an absolute value. Now that might not make a lot of sense, but it will once I explain it. Let me just get up a I'm going to write out this here. So if we have a number line, and this is 0, and if we have 3 and negative 3, the distance to both is 3. And this is pretty much an absolute value, because the value is always positive, it's always a 3, but x here is negative 3 and 3. So it's, kind of, the absolute value is the distance from the center to both points. It's, kind of didn't really make sense when I first learnt it, but I kind of got along with it. First example that we're going to do is find absolute value of negative 3. Okay? Absolute value of negative 3. We did it up here, really. It's actually 3 units away from the center, so it's just 3. Okay. Now, I'm going to do a harder one. I'm going to push this up. Oops. Evaluate 2, square absolute value of 2, minus the absolute value of minus 1, plus absolute value of minus 3 squared. Deal with each term. So we have a 2 minus the absolute value of minus 1. Well, the absolute value of minus 1 is just equal to 1. So it's minus 1 plus absolute value of minus 3 is 3. And 3 squared is 9. So we end up getting 1 plus 9, which equals 10. Okay. Okie dokie. I'm going to do more of an algebraic one. Write expressions for the absolute value of 2x minus 4 without absolute value signs. Well, the absolute value of 2x minus 4 can indeed equal 2x minus 4. Can equal either the positive or the negative, right? And I guess, you know, if we look back at this definition here, the positive is when it's, if we look at this definition back here, when x is greater than or equal to, we get when 2x minus 4 is greater than or equal to 0, so 2x is greater than or equal to 4, x is greater than or equal to 2. And we also do the same for this one, or equals minus 2x minus 4, which equals, sorry, since there's the minus, if you look back at this definition here, when x is lower than 0, we get 2x minus 4 lower than 0, 2x is lower than 4, x is lower than 2. And there are our two answers. I think that's just about it. You know, again, I kind of went over it pretty briefly, so if you have any questions, hit me with an email or message me on YouTube, on here. And yeah, I hope you enjoyed this basic arithmetic series, and I hope you learnt pretty much most of the basics. And I do apologise for the way that I quickly went over it, because, you know, I find it quite boring actually, so yeah. But don't forget to subscribe, and I'll see you next time.